Hello, welcome to this lesson of our study of calculus 1, particularly or mainly in limits and continuity. Okay, so today we're just going through what we mean by asymptotes. Okay, all right, so when we say asymptotes, what are the forms of asymptote that we have? We have mainly two forms. Okay, we have the vertical asymptotes, which is of the form s equals a. Okay, is of the form s equals a, and then we have the horizontal asymptote, which is of the form y equals a. Okay, but in some cases we'll have an asymptote that is a line, an equation of a line, that is the slant or oblique asymptote, that is y equals some constant. Is it the equation of a line? Okay, so with the a, that is a slant, is of the form y equals mx plus c, and then they all happens at some point, or they have their conditions where they happen. Okay, so I'll explain them to you. And then we have the b one, which is the curvilinear, which will be y equals ax to the power n plus bx to the power n minus 1. You see, just a polynomial like that going. Okay, that is when we have, this is the oblique or slant asymptote, and the last one is a curvilinear. It's an asymptote of a curve form. Okay, all right, so when we say vertical asymptote, what do you mean? If you have a function, let's say a rational function f of s equals some p of x, okay, over some q of x, then with the vertical asymptote va, let's call it va. Okay, we just want to look to we want to find the values of x that will make this function undefined. Okay, and for a rational function, the only values that will make this function undefined is when the denominator is equal to 0. Okay, but before we represent f of s as p of s over q of s, okay, you should make sure that they both have no other common factors, okay, apart from 1. Okay, so their common factor should be just 1, and that is plus or minus 1. That is all. If they have other factors, you have to factorize them, cancel them out before you can find the vertical asymptote. Okay, so in a graph form, this is how the vertical asymptote looks like. Let's see if I have a graph like this. Okay, and I want to find the vertical asymptote. The vertical asymptote, like I said earlier, I said that it's of the form what s equals a. Okay, so if you have a function, you want to find the equation of the line, which is just an x value, that will be in a vertical asymptote, meaning it's a vertical line. Okay, so let's say if here was a, let me erase that. Let's say if here was a, then the vertical asymptote will be like this, just a straight line through a. Okay, like that. That will be the vertical asymptote. Okay, it's just a straight line that how do you call it, cuts the x-axis at the points x equals a. Okay, so let's say if this is x-axis and this is y-axis, then that will be our vertical asymptote. Okay, and like I said, before you can find it, you have to equate the denominator of your rational function to 0. Okay, so the values of x that will make this function 0 is our vertical asymptote. I hope you understand this. Now we can go to the horizontal asymptote, which I call it the HA. Okay, with the horizontal asymptote, given a function, let's say f of x equals some p of x over some q of x. Okay, then with this, the horizontal asymptote is just an equation of it's just an equation of a line that is on the y-axis. Okay, so it's just a horizontal line. Okay, let me draw that graph first before I talk about how to find it. Okay, this is how the graph looks like. If let's say, like I said earlier, if let's say this x-axis and this is a y-axis, and like I said, the horizontal asymptote with a constant one is just y equals a or y equals b. Okay, let me use b here, and if here is b, then our horizontal asymptote looks like this. Okay, sorry, let me use a straight line. This is how the horizontal asymptote look like. Okay, it's just a straight line cutting the y-axis. Now with this line, if you have a curve, the curve will never touch it. So that's what we mean by asymptote. The curve will never touch that asymptote you are talking about. Okay, now to find this asymptote, this is what you have to do. You have to find the limit as s approaches infinity, okay, of your f of x, just like that. Okay, so simply f of s is, if f of s is a rational function like we've done here, then this is how it will be like. Okay, but we have a shortcut way of finding the horizontal asymptote. So in the process, I will teach you how to find them in a shorter way. Okay, so I'll give the shortcuts in a way as we are solving the questions. Okay, all right, so let's talk about the slants one. With those ones, they come with condition: the slants asymptote or the oblique, okay, asymptote. Okay, with that one is the same thing. Okay, given f of x is a form of horizontal asymptote. That one too is y equals something, but here is a curve. Sorry, it's a straight line. Sorry, f of x equals p of x over q of x. Okay, now the slant asymptote comes in when you have the degree, okay, the degree of p of x, okay, being greater than degree of q of x just by 1. Degree of q of x just by 1 unit. Okay, meaning that you can have the degree of p of x to be what, 2. Okay, the degree can be 2, and then the degree of q of s to be 1. This is greater than this by 1, okay, by 1 unit. Or you can have 4, 3. So once you have that condition happening, that the degree of p of x is greater than q of s, that of q of s just by 1, and you have a slant asymptote. With that, you have to perform polynomial long division. So you have to do this. You have to divide p of x by q of x. Okay, when you divide that, whatever quotient you get here, the quotient, let's call the quotient, let's say r of x. Okay, with that, no, that will be the remainder. Let's call it small q of x. Okay, to know that it's a quotient. Okay, then this q of x here will be a slant asymptote. Okay, so with the slant asymptote, equation is y equals this q of x, the quotient you get. Okay, so in that manner, since it is just greater than it by 1 unit, you have to get something x plus c. So you get mx plus a constant. Okay, now let's talk about the curvilinear one, the curvilinear asymptote. With that one, you have f of x being equal to p of x over q of x. Okay, and that with this the asymptote is also a curve. That is why we call it curvilinear. But the condition is that the degree of p of x, okay, is greater than that of q of x. You should know by now that of q of x by 2 or more units. Okay, so it's greater than it by 2 or more units. So let's say the degree is 5, and this one, the degree is also, for degree of p of s is like, let's say 5, and degree of q of s is, let's say 3. Or this can be 10, and this can be 5. Okay, if it is greater than it by 2 or more, then we have a curvilinear asymptote. The kind of asymptote this will have is curvilinear. Okay, and with that, the same thing happens. You have to divide just p of s by q of x. Okay, and with this, you get a quotient q of small q of x. Now with this quotient, it will be either a quadratic function or higher degree polynomial. Okay, so you have your asymptote to be y is equal to q of x, small q of x, and that will be ax to the power n plus bx to the power n minus 1 plus that like that plus a constant. Okay, so it can be a polynomial of order 2 or 3 or anything. I hope we are okay with the asymptotes. Now let's take an example for each of them and then go through them. So vertical asymptote, find the vertical asymptotes of the following functions. So we have these functions. The first one is f of s equals that, the second is f of s is this, and the third is that. Okay, so let's go ahead and solve it for the first one. With the vertical asymptote, I first said that what you have to do is make sure that the common factor between the numerator, so you can see that this is of the form p of x over k of x. Okay, it's just a rational function. So here p of s is what? Just the numerator, and then k of s is the denominator. Okay, so what you have to do is try to factorize both the numerator and denominator and see if they can cancel out. Okay, some of them can cancel out. So if you factor the top one, I hope by now you know how to use a calculator to factorize a quadratic function or do factorization of quadratic function by yourself. And this will give me in one bracket x minus 4 multiply another bracket 2x plus 3. Now if I factor the last one, the down one, this is what you have, x minus 4 in another bracket s minus 1. Don't worry, I'll have time to go through a shortcut. I'll be doing videos on how to find or factorize polynomials. Okay, so in no time I will do them, but for now I hope you can find ways and means to know how to factorize these. Okay, so you can see that x minus 1 is at the top. Okay, so this can take this out, and we'll have f of x to be equal to 2x plus 3 over x minus 1. So with this, the new p of x and q of s we've got here, okay, this is our new p of x over q of x, the new one. Okay, this is what we are coming to use here, because we have to make sure that the common factors between them is just 1. So since there was this x minus 4 factor, we had to cancel them out. Okay, then we come and apply our rule. So how to find the vertical asymptote? We said that is the values of x that will make this function undefined. Now having a function of this form, 2x plus 3 over x minus 1, to find the values of x that will make this function undefined is only when x minus 1 is equal to 0. So you solve for this equation. Like I said, you have to equate the denominator to 0 and you find the values of x. So you have to get x equals 1. So the vertical asymptote here, VA, for the function we're talking about, that is the whole function, this function. Okay, this 2s squared minus 5s minus 12 over s squared minus 5s plus 4, its vertical asymptote is given by, so it's x equals 1. Now if you could see in our simplification, we had a common factor between the terms, which is x minus 4. Okay, with this, when you equate this x minus 4 to 0 and you solve for x, we call this term a whole. Okay, so this is called a whole. So the whole in the function f of s that was given is actually x equals 4. So you have to know the difference. The vertical asymptote is the values here that will make this function undefined, and then the whole is the common term that will cancel out. You just take it, equate it to 0, and solve for your x. Okay, all right, so let's move on to the next one. Now with this one, we have to try to ask ourselves if you can factorize this. With the second one, f of x is actually equal to, with the top, the numerator is in its simplest form, but the denominator is like this, x minus 1, x plus 1, and still it can't cancel any of the terms in the numerator. So what you do is just equate the whole of the denominator to 0 to find your vertical asymptote. Okay, so we have to equate x minus 1, x plus 1 equals 0. Now with this, you can take, how to do such questions, okay, or such problems. So what we have to do here is you take x minus 1 equals 0, so x equals 1. with the first vertical asymptote. Then you have x plus 1 equals 0, and you have x equals -1. So the vertical asymptotes here, VA, okay, you can call it anyhow. That is my way of calling it VA, okay, is x equals plus or minus 1, or you can separate them by saying s equals 1 and, okay, the vertical asymptote is s equals 1 and x equals -1. You can separate them like that. Okay, so I hope this is cool. Now let's move on to the next one, the third one, which we have y equals 2s squared plus 4 over 2 plus 7s minus 4s squared. Okay, so with this, what we do is normally we try to factorize things. Okay, so f of x is equal to, with the top one I can factor 2 out and I have s squared plus 2. Okay, I hope this can be seen here. Then with the denominator, when I try to factorize it, is x minus 2 multiplying 4x plus 1. Okay, you can do this, like I said, on your own, how to factorize quadratic functions. Okay, now you can see that there is no term that can cancel out, so all I do is I just equate the denominator to 0. Okay, 4x plus 1 equals 0. So with the first term, or with the first part, we have, let me clean it, draw this straight line here. Okay, so with the first part we have x minus 2 equals 0 and x equals 2. It's a horizontal, sorry, it's a vertical asymptote. Okay, it's the first vertical asymptote from the first bracket. Okay, so x equals 2. And then with the second one, 4x plus 1 equals 0. So we have 4x equals -1, x equals -1 over 4. It's also a vertical asymptote. Okay, so the vertical asymptote for this function here, VA, is actually given by s equals 2 and, okay, s equals -1 over 4. These two are the vertical asymptotes for this function. I hope you understand vertical asymptote now. I believe this will be okay for you to understand every vertical asymptote. Like I said, if you're able to factorize terms and some terms cancel out, that term that will cancel out is called a whole. Okay, that is what I told you. All right, so let's move on to horizontal asymptotes. So find the horizontal, oblique, or curvilinear asymptotes for the following. The reason why I just combined them is that I said that the horizontal asymptotes, in the general way or in the more simpler way, is y equals a constant b. Okay, but when y is equal to a function, a linear function, or a curve, then we have a different name for it. But they are all forms of horizontal asymptote. But normally what most teachers would teach is the constant aspect, that is y equals b. Okay, but I'm teaching everything here so that you understand it forever. All right, so with the first one, let's go ahead and solve it. Okay, sorry, with the first one here, y equals this. Now I can just straight away write the horizontal asymptote. Let me write the answer and I'll show you the way. Okay, the horizontal asymptote is y equals 0. That is the solution. You are wondering how, right? But then let me show you. What you have to do is, first of all, the first way is, like I said, define the limit as s approaches infinity of your f of x. Okay, which in this case will be limit as s approaches infinity of the whole fraction 6s to the power 4 minus x plus 2 all over 7x to the power 5 plus 2x minus 1. Okay, so limits to infinity, what you do is you find the highest degree polynomial or the highest power of x in the whole of the fractional or the rational function, and the highest degree here is 5. Okay, so it's s to the power 5. So what you do is you divide every term of the denominator and divide every term of both the denominator and numerator by x to the power 5. Okay, so you have limits as s approaches infinity of, divide every term of the both numerator and denominator by x to the power 5, and that you get 6 over x for the first one. You have 6x to the power 4 over x to the power 5. You have to get this. Then minus 1 over x to the power 4, then plus 2 over x to the power 5. All being the numerator. Then you come to the denominator. Then you have 7 here plus 2 over x to the power 4 minus 1 over x to the power 5. Okay, I hope you can see this. Now with this, if I plug in infinity straight away, 6 over infinity means 6 over a bigger or a larger value. So 6 over, let's say, 10 billion will approximately be 0. Okay, and minus 1 over infinity to the power 4, and that one too will be 0, plus 2 over infinity to the power 5, that one too will be 0. So the whole numerator is 0. Okay, over here to 7 is just there. Okay, so 7, then 2 over infinity to the power 4 will also be 0, and minus 1 over s to the power 5 will also be 0. So you have just 0 over 7, and that will give me what? 0 over 7. 0 over any number is what? 0. Okay, so you can see that my guess was right. This solution is right. Okay, so how was I able to predict the answer straight away like that? Let me show you. Okay, let me try to show you. Let me clean this part, and after cleaning it, I will explain to you, or I'll give you a shortcut that the moment you see any rational function, you can guess or write away the horizontal asymptote straight away without calculating for it. Okay, so what you do is you have to simply check the degree of the highest degree of the numerator. Okay, the highest degree here is 4. Okay, you check it, 4. Then you check the highest degree of the denominator, and that is what? 5. 4 is less than 5. Okay, so what we know is that this is for numerator. Okay, and this is denominator. Okay, so when the degree of the numerator is less than the denominator, the answer is the horizontal asymptote is y equals 0. Whenever it is less than that, this works. Okay, so the horizontal asymptote HA for this question is y equals 0. So that was the shortcut I used. Okay, so you don't need to go through all the limit process. And let's look at this question as well. Now with this question, I have a horizontal asymptote. That one too, I'll show you the answer straight away, because with the curvilinear and then the oblique or slant, you said it only happens when the numerator degree is greater than the denominator degree, right? But here the questions we've been solving, it's not true. It's not like that. Okay, that is why we are just going through them. Now with this, the answer is y equals 3. That is the solution to this. That one too, I'll show you the shortcut after we go through the process. Okay, so simply, quickly, how do you find the limit? The limit as s approaches infinity. Okay, then with this, I'm just dividing through by the highest degree for the denominator for both the fractional function, or the both numerator and denominator is 3. Okay, the highest degree here is 3, so I have to divide through by 3, like s to the power 3, like that. So 6 minus 2 over x plus 1 over x squared, or x cubed, right, over 2, then plus 5 over x cubed. Okay, now with this, if I plug in infinity, here will be 0, here will be 0, here will be 0, so I'll be left with what? 6 over 2. Okay, and that will give me 3. So my horizontal asymptote, like I said, is an equation of y, just y equals 3. Now I was able to also predict this as well. So the question is how did I do this? Okay, now with this, what you do is, whenever the degree of the denominator, okay, so when degree of the numerator, okay, is equal to degree of denominator, okay, as the highest degrees, and they are the same, the horizontal asymptote is y equals the coefficient, okay, of the highest degree, okay, of numerator degree over the coefficient, okay, coefficient of denominator degree. That is how it works. Okay, so the coefficient of, when you see this function, the coefficient of the degree here is s to the power 3 or 3. Okay, the degree is actually 3, so it's s cubed. Now the coefficient for the numerator is 6 and the coefficient for the denominator is 2. So when I divide, I get 3. That's what we got. Okay, so there's a shortcut for solving for horizontal asymptotes. Okay, when the degree are the same and the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is s equals 0. Sorry, y equals 0. Okay, I hope you understand this. So that's the shortcut for it. Now let me write my answer. Okay, so with this, you know that our HA, I'm writing it down here. Our HA is given by the horizontal asymptote y equals what? 3. That is it. Okay, now let's move ahead to the slants or oblique. Okay, this happens, we said that the slant or oblique happens when the degree of the numerator is greater than the degree of the denominator by 1 unit. Okay, so you could see that 3 is greater than 2 and the difference is just 1. Okay, that's 3 is the degree for the numerator, and then 2 is the degree of the denominator. So what you have to do here is, here there's studious work here. Okay, but we just go through it straight away like that. Okay, all right, so what you do here is you perform what? Polynomial division. Okay, all right, let me put it there like that. So I have to divide 2s cubed minus 3 by s squared minus 1. Okay, so dividing this, s squared will goes into s cubed how many times? Just x. Okay, it's 2s, so it's 2s cubed, so I have to go into it 2x. When I multiply this 2x by s squared, I have to get 2s cubed. Okay, then 2s cubed, then when I multiply by that, I get minus 2x. Okay, all right, then I subtract them. So s cubed minus 2s cubed minus 2s cubed, I get 0. There is no x term in this one, in the long division sign, so it's just 0x there. Okay, so you could have also, if it will confuse you, you have to write it in a general cubic form. Okay, so it's plus 0s squared plus 0x minus 3. This is how it was supposed to be. Okay, so when I come to the x component, I have 0x minus 2x, so I have plus 2x minus 3 because there is 0 here. Okay, all right, so s squared can never go into x. Okay, it has to go into it. I think 1 over x, but we don't want a fractional term in here. Okay, so what we have to do is we just have to write it like this. So the quotient that we had, we don't want to talk about the remainder because this is the remainder and we don't need a remainder. Okay, all that we need is the quotient. Okay, the quotient that we had here, or you can once again write f of x in terms of what we have done. So f of x can simply be equal to the quotient 2x plus the remainder 2x minus 3 over our dividend, which is the s squared minus 1. Okay, so here we said that the quotient that is here, that is a small q of x. If you remember in our introduction, that's what I said. Okay, so the q of x here now is what we call the slant or oblique asymptote. Okay, so y equals 2x. Okay, if you remember, I said that this is a slant asymptote. Okay, so let's say SA or oblique. Okay, if you remember, I said that the slant asymptote is a straight line. This is indeed a straight line. Okay, it's just plus 0, it's ms plus c. Okay, so we have 2x plus 0 like that. Okay, so let's move ahead and go ahead and then do one example on the curvilinear. Okay, and I think that will be all for this video. Okay, with the curvilinear, if you remember, we said that the degree of the denominator or the degree of the numerator should be greater than the denominator by 2 or more units. Okay, so 5 is actually greater than 2. That's the highest degree in both cases. Okay, and this is greater than it by what, 3 units. So this is indeed a curvilinear case here. So the asymptote that will happen here is what we call the curvilinear asymptote. Okay, so with that, we said that you have to perform a polynomial division. Okay, so with the polynomial division, this is how it goes. Like you have s squared plus 1. Okay, so I have to write s squared plus 1 like that, dividing or going into 3x to the power 5. Okay, 3x to the power 5 minus x to the power 4. Then there's no s cubed, so plus 0s cubed, then plus 2s squared, okay, plus x plus 1. Okay, so with this, s squared will go into 3s to the power 5. How many times? It goes into a 3s cubed. Okay, so multiply it through this equation, you have 3s to the power 5. Then you don't have any s to the power 4 here. Multiply, you have plus 3s cubed. Okay, like that. Then I have to subtract everything. Okay, so when I'm subtracting everything, I'll get 0 here. I have minus x to the power 4 minus 0x to the power 4, so I have minus s to the power 4 again. Then 0x to the power 3 minus 3, so I have minus 3s cubed and plus 2s squared plus x plus 1. Then you ask yourself, how many times will this goes into this? Okay, so s squared will go into minus s to the power 4. How many times? Minus s squared. Okay, multiply through it, I get this. If you remember, I believe by now you know how to do polynomial division. So plus 0s cubed, then minus s squared. Okay, so I subtract everything like that. When I subtract, I'll have 0 minus 3 this, then minus 3s cubed, then plus 3s squared, plus x plus 1. So you continue like that. S squared will go into this minus 3x. Okay, then multiply it to it again, so you get minus 3s cubed. Okay, minus 3s cubed and plus 0s squared, then take minus 3x, right? So minus 3x. So you subtract again. When you subtract, what will you get? So let me push this to the top small. When you subtract, you have to get 0 here. Okay, plus 3s squared, because 3s squared minus 0s squared, you have that. Okay, so no, plus 4x plus 1. So 3s squared and s squared. S squared will goes into 3s squared. How many times? It goes into it 3. Okay, so let me push it to the top and then write it here. Plus 3. Okay. This is tedious, but then let's go through it. We are almost done. When you multiply 3 to that function, this is what you're gonna get. Okay, let me push it to the top again. You're gonna get this how do you call it, 3s squared again, then plus 0x, then plus 3. Okay, so when you subtract as well, this is what you get. You get 0 plus 4x plus plus, or is it plus? No, minus 2, right? So minus 2, that will be the remainder. Okay, I think this will be the remainder. So that is the quotient is there. We've gotten our quotient. This is what all that we need. Okay, the quotient here is a small q of x, and this is our curvilinear asymptote. Okay, so q of x here now is equal to 3s cubed minus s squared minus 3x plus 3. So with this, you know that y equals the quotient, which is q of x minus s squared minus 3x plus 3, is our curvilinear asymptote. Okay, our CA. All right, I hope this was okay. Now, thank you, and don't forget to subscribe to my channel. In our next discussion, we'll go through how do you call it, evaluation of limits, okay, evaluating some limit functions as well. Okay, so don't forget to subscribe to my channel and see you next time. Okay.